Weber Warrior Forever. What up, guys? How's it going? Just in my office right now. My virtual reality room / grandkids room / there's my Star Wars Yoda box / office / gonna build a cupboard there, extend our cupboard. That's gonna be fun. And there's our VR system. Woo! Love VR. Just need some time to play. So I'm making for you guys right now this video to help you. Here we go. Let's us. Whoa, super frozen. Still recording? Sorry guys, technical difficulties. My computer's like, ooh, what do I do? There we go. Okay, so we're just gonna run through this real quick to help prepare you for the rationals test. Bum bum bum. Rationals test. Knowledge is power. So to prepare for that, we're doing the Unit 4 practice test. And so with that Unit 4 practice test, the first one is just reducing rational expression. A lot of people missed that on the last test. The other teachers wanted us to kind of include this. So basically, if you can divide all three terms by something, you should. And you want to do the GCF, the greatest common factor that they all have in terms, to get it simplified as possible. Because if you divide by 2, divide by 2, divide by 2, then you'll end up with this answer. But then that could divide even more. Remember, the x's can't cancel, the 24 and 48 can't reduce because it's connected because of the addition symbol. So we are just going to, what do they all have in common? They all have a 6 in common. On the test, it could be a 3 or a 5 or a 4 that they all have in common that you could reduce by. And so 24 divided by 6, 24 divided, whoa, it's more than 6, Newbold. Is it? Oh, maybe it is. Maybe it's 12. I didn't even think of that. Wow. So even 6 isn't the greatest common factor because you could divide by 2 one more time after you do divide by 6. You could divide by 2, and that's another way to do it. But we're going to divide by 12. So 24 divided by 12 is 2x. 36 divided by 12 is 3. And then 48x divided by 12 is 4. So there's our right answer. Nice. Okay, the next one is exclusions. Remember that when there's just a number by itself on the test, that it's just going to be a 0. Just a 0. Nice, nice. Question 3, doing inequalities. So do you remember how to do this problem, inequalities? So basically you set the top equal to 0. Factor it if you need to. Factor it, get everything on the left side. So set the top and bottom equal to 0. Do a number line. So it's going to be opposite what you think, right? So instead of a -9, you're going to add 9 to the other side. It's a +9. Instead of a +4, it's a -4. And then you have to choose test points. Now remember, because it's less than or equal to, that means the top is going to be a closed dot, and the bottom is always an open dot, because you can't have -4, because -4 plus 4 on the bottom is an exclusion, because that means 0, and you can't divide by 0. Cool. So then we're going to go ahead and do a test point. So -5, 0, and then 10. And then you just plug each of those in. And so we're looking for where it's less than 0, so that means only negative numbers. Do you guys remember this part? So less than or equal to 0 is only negative numbers. And so when you plug in, for example, 0, when you plug in a 0, you get a -9 on top divided by a +4 on the bottom. And -9 divided by 4 is a negative number. Negative. And then it turns out when you plug in a -5 and a -9, you get -14. When you plug in a -5 with the 4, you get a -1. A negative divided by negative is a positive. And then plug a 10 in. 10 minus 9 is 1. And 10 plus 4 is 14. and it is a positive over a positive, so a positive number. So then our answer here is just going to be where it's negative, and then don't forget that it's a parenthesis where it's open hole and a bracket where it's closed hole. So the answer here will be parenthesis and -4, and then from -4 to 9 is where our answers are all negative, and then a bracket. And that's it. Nice, nice, nice. Vertical, horizontal asymptotes. These are actually really quick and easy. So vertical asymptotes at the bottom equal to 0. So when you set the bottom equal to 0, you're just going to get a 2. And because you set the bottom equal to 0, you add 2 to both sides, and so you just get a positive 2. Then the horizontal asymptote, well, the powers are the same, so that means you're just going to use the numbers in front. So 1 over 1 is just 1. Nothing cancels in the top and the bottom. Nope, nope, nope. So you're just going to put none there, or select none, or type in none. And that's it. That's it for number 4. Number 5, we're also doing the same thing. So basically the vertical set the bottom equal to 0. So we get not a positive 4, but a -4, opposite sign. The horizontal asymptote, powers are the same again. So we're going to use 3 over 1. Now, since you're watching this video, I'll give you a hint. So y equals 3 for the horizontal asymptote. So since you're watching this video, I'll give you a hint. So on the test, I did make it a tiny bit harder. And I went ahead, something like this, not exactly, but I went ahead and put a squared right here, right? And then left x to the first power in the bottom. Maybe changes to -4, I don't know, or +4. And how that'll change this problem is that when top is greater than bottom, that means the horizontal asymptote is what? Do you remember? If top is greater than bottom, yeah, so that's just going to be a slanted asymptote or diagonal. So it's actually going to be none, right? It's just going to be none for the horizontal for the test on one of these problems. I won't say which one, but one of them you will have top is greater than bottom. So watch out for that, for the horizontal asymptote. Nice, nice. Okay, the removal discontinuities the whole. Does anything cancel? Can the x's cancel? No, because it's connected by the umbilical cord, the plus symbol. So again, we just say none. Beautiful, beautiful. Okay, next one. Ooh, lots of factoring going on in this one. So you're going to factor this one on the top and bottom, or you can graph it too to see. You can see where the asymptotes are. You can see if there's a hole. A little bit tricky to see where the hole is. You'd have to look at every single point. That would be crazy. Let's change to blue now. So what are factors of 15? Pause me. You know this. Pause me. Pause me. Do you know factors of 15? Okay, you can push play now. So 3 plus 5. And so 3 plus 5. So 5 plus 3 is 8. And then 5 times 3 is 15. So that's the right factoring there. And then what are factors of 12? Well, factors of 12 are 3 times 4 with a difference of 1. So a -4 and a +3. Nice, nice. Now we were going to have 2 vertical asymptotes at -3 and +4, and that is an answer on the test, or on the practice test, so be careful, don't choose that one. Choose the answer where these are canceled, because those are identical, so those can cancel. So the vertical asymptote is only +4. The horizontal asymptote is just 1 over 1 again, which is just 1. And then there is a hole at x equals what? Not a +3. Remember, you have to set it equal to 0 and -3 to the other side. So there's a removable discontinuity at -3. -3. Nailed it. Okay, so then in preparation for graphing, we've got lots of things to fill in here. But really, it's if you've practiced this enough, you're going to ace it on the test. So simplest form, it's already there. You can't really cancel anything out on the top and bottom. So just 9 all divided by x minus 9 is the right answer. The holes, removable discontinuity, since nothing canceled on the top and the bottom, it's none. The x-intercept, well, really, let's look at the horizontal asymptote first. So this is x to the first power. This doesn't have an x, But technically, we could write x to the 0 power, which just equals 1. You can multiply anything by 1. So 0 is less than 1. Remember, if top, you remember this part? So if top is less than bottom, it's just y equals 0. Remember Bobo? Bobo. Big on bottom equals 0. Bobo. So top is less than bottom, then y equals 0. So the horizontal asymptote is just going to be 0, and that means that the x-intercept is going to be none and none. But if you're not sure, you could set the top equal to 0, which 0 does not equal 9. Or you set the whole thing equals, set y equal to 0 is what you're really supposed to do. But the problem is when you set y equal to 0 and then you multiply x minus sign to the other side, that goes away because 0 times anything is just 0. You end up with 0 equals 9, which doesn't exist. So yeah, so just none and none. Okay, but to find the y-intercept, you remember how to find the y-intercept? So to find the y-intercept, you set x equal to 0. So we go back to our simplest form, and we set x equal to 0, and that goes away. So you just end up with 9 over negative 9. And 9 over negative 9 just reduces to negative 1. And so again, what did we do? We set x equal to what? We set x equal to 0 to find the y-intercept. That's the first part of our answer. And then we get y equals negative 1. I think even if you put 9 over negative 9, I think I still gave it to you on that fill in the blank there. Okay, vertical asymptotes at the bottom equal to 0. We just get a positive 9. Nice. And the 9s cannot cancel. No, no, no. Don't do that. Okay, so the domain is all real numbers except for our vertical asymptote at 9. And the range is all y values except for our horizontal asymptote, which is 0. Nailed it. Probably do one more video. What are we on for minutes here? 11 minutes? Me? Let's see, that was number 7. So number 8, very, very similar. Very similar for number 8. Just need to factor it first. But yeah, we'll do a second video just to keep these short, keep your attention span going. So 8, 9, 10, 11 is next. Thanks for watching. You behind the screen. Thanks for watching. Woo!